And after kinematics, you're going to read about dynamics. That means once you know how the object is moving, you need to ask yourself, what is making this object move? And that's when the concept of force comes into picture. And that's when you learn about the 3 laws of Newton. First law is the law of inertia. The second law gives you force equals mass into acceleration. It tells you, actually, this is not what it tells you directly. It tells you that force is directly proportional to the rate of change of momentum. mv, mass into velocity, is the momentum. So this is what it tells you, right? And we assume if mass is constant, if mass is not changing, that means it's not like a sand trolley and there is a hole in the trolley. If that is moving, then the mass is changing, right? Mass is decreasing. Not that case. Some case where mass is not leaking or mass is not getting added up. Only for such cases, this thing gives you force equals mass into acceleration. Otherwise, you get some extra terms also. Okay. So this is the second law. And the third law all of us know is the law of action and reaction. So F force on one by second object is equal to force on the second object by the first object, but it acts in the opposite direction. Okay, so this is Newton's third law. But these things you've already studied. So what is new this time? This is what is new. Acceleration being variable, what to do then? Then force is given by this. Force is equal to dmv upon dt. And when you learn about differentiation, you would be able to see that the formula to differentiate two functions that are multiplied is this: m dv by dt plus v dm by dt. This will give you the net force. Okay, so this guides rocket propulsions as well and all other forces in mechanics. So if the mass is constant, that means rate of change of mass with respect to time is 0, then you can say, okay, force is equal to mass into acceleration. And that's pretty easy to see. But like rocket propulsion, okay, when a rocket goes up, a large fraction of its mass is the fuel. Fuel gets burnt up. So the overall mass of the rocket keeps on decreasing. So then this formula will not work. You would have to go with this formula because there is a decrease in mass. There is actually, this has some value now. Okay. So in such cases, we're going to need this formula. And whenever we talk about Newtonian mechanics, we talk about forces. There are different types of forces. Again, a quick refresher for those forces. You've already seen those forces. Forces like the tension force, the normal reaction force, very, very important, normal reaction force. The gravitational force, of course, the pull of the earth. And there are other kind of forces. Electromagnetic forces would be one. Spring forces and whatnot. Okay, plenty of ways to classify forces. This is important to understand. This is important to understand. And this, if you understand these three, I think it should be fine for the first few months of class 11. Now, once we have gone through the different types of forces, we can look at the free body diagrams. Free body diagram is basically representing all the forces acting on an object at a given time. Why do we need that? We need that to write the equation of motion. Let's take a look. So free body diagrams are showing all forces acting on a body. Remember, acting on, not acted by the body. Okay, whatever that body is applying on other bodies, we're not concerned about those forces. Only what forces are acting on the body. So if I have to draw the free body diagram of this block, I only take a look at what are the forces acting on this block. This person is pulling it, right? So in this direction, definitely a tension force will act. This object would have some mass. So Earth is going to pull it down towards itself. So some mg force will act on it. Yeah. If this is a frictional surface, right? It's a rough surface, then a frictional force will oppose the motion of this block. This would be the frictional force. And since this block is pushing the ground with this much force, the ground will also push this block up, and that is what is the normal reaction force. So these are the four forces, and this representation is called the free body diagram of this block. Similarly, try drawing the free body diagram of this block, assuming this angle to be theta. Okay. And this is rough surface. But this is what you have to do when you draw free body diagrams. First thing, separate the body from the setup. This body, you separate it from the setup, okay? Just the body, nothing else. No wedge, nothing else. Now, draw the forces. One is the mg force, or the gravitational pull of the Earth. The other would be the normal reaction force, which the surface of contact is exerting on this block. And the surface of contact exerts forces only normally. So in this direction, normal reaction by the wedge on the block. Now, the tendency of this block is to slide down. This block will try to slide down. So frictional force is going to oppose this motion. There'll be a frictional force acting in this direction. Any other forces? These are all the forces that are acting on it. Okay, no other forces. Now, what to do after this? That's another matter. If you have to find out what is the acceleration of this block, you would have to do something called force balancing. So what you do is, we know mg is acting this way, normal reaction acting this way, frictional force acting this way. We have to find out the acceleration along the incline. So find out all the forces acting on this object along the incline. That is where resolution of vectors comes into picture. You will learn about that later. Okay, you will learn if this is theta, this is theta. So this component turns out to be mg sine theta. See, this is simple trigonometry, nothing much, but you would be taught how to split a vector into its components. This is mg sine theta, and this would be mg cos theta. So now, I want to tell you why we need free body diagrams. In order to find out acceleration, we need to know all the forces acting along the incline. So along the incline, I can write the net force. That means all the forces is responsible for the acceleration of the block, yes or no? From Newton's second law, all the forces acting is responsible for ma. This net force is equal to mass into acceleration of the block. And this is what I have to find out. So what are all the forces? In the downward direction, it's mg sine theta. In the upward direction, it's the frictional force. So downward direction, write mg sine theta. Upward direction, write the frictional force. How to calculate frictional force? That is another story. You will learn that later. Mass into acceleration. Now, this equation will give you the acceleration of this block along the incline. That is why we need free body diagrams. Very crucial concept, very critical.